Hello everybody, this is Calculus BC 2016. We're doing question number 4. Man, test is coming around the corner. I'm hoping you guys are working hard. It's going to pay off. You guys will do fine. I'm confident. So part A, you want to find the second derivative. So let me emphasize a couple of things here. Your function is y, your variable is x. Well, that's fine. That's an x. So you just take the derivative normally. But that's not x. So you have to treat it as box, as we call it box. So the second derivative, well, derivative of 2x, x squared is easy, it's 2x. But what's the derivative of negative 1/2 box? It's negative 1/2 times the derivative of box, which is dy dx. But they want this answer with only x's and y's. They don't want dy dx's. So I replaced dy dx with what they told us it was. And that is the answer. We are done with part A. Let's go to B. Hopefully this will be quick. So f of x is a particular solution. So what they're saying is we have this is the actual function. And it goes through this point. They want to know if that point is a minimum, maximum, or neither. So we have two options. You have the first derivative test and the second derivative test. So let me kind of review that real quickly. So the first derivative test says first you find a critical point. Step 2, you find the slope left and right of that critical point and see what happens. If the slope changes from positive negative, but we actually the derivative changes from positive negative, then at that point you have a relative max. And similarly for the rel min, you would find a critical point and then you find the slope to the left and to the right. If the derivative goes from negative to positive, you have a relative min at that critical point. That's not going to work here, and here's why. Well, first, we can do this. We have to make sure we have a critical point. Whether we're doing the first derivative test or the second derivative test to find, well, technically with the first derivative test you wouldn't need. I'll show you why the first derivative test doesn't work. We need to find the derivative to the left and right of negative 2, 8. So we make our box, and I'll do this real quickly. This will be the point x is negative 2. So I could pick like negative 3 and 0. X, f prime of x. Well, f prime of x is dy dx, right? So what's dy dx at negative 3? The problem is you need the y value. What y value do you choose? You don't know because the curve could be going up or down. You can't find dy dx because you could plug negative 3 for x, but what's y? What does a curve do as you go from negative 2 to negative 3? You don't know that, so therefore you can't find the first derivative. Therefore we have a problem. Therefore we go to the other test where we say, hey, if we find a critical point, bam, and at that critical point, the graph is concave down, then you must have a relative min. And similarly, if you have a critical point, and at that point, the graph is concave up, then you have a relative min. So that's the approach we're going to take. First derivative test does not work. We can't do it. So we want the second derivative. So we want the second derivative at xy equals negative 2, 8, which will be 2 times negative 2 minus 1/2, 2 squared, minus 1/2 times 8. Is that positive or negative? Let's see. 4 minus 4. Oh, that's negative, because that's negative 4. No. Whoa. I don't want it negative. I want it to be 0. Am I messing up? It should be 0. Did I mess up? Let me double check my work here. 2 times negative 2 minus 1/2 negative 2 squared. That doesn't make a difference. Minus 1/2 y. Y is 8. Oh, loser, loser, pants on fire. What am I doing? This is the second derivative. So the second derivative comes out negative 4, but that means it's concave down, right? But how do you know you're not there? And that's not a relative max. You got to make sure you're at that critical point. So we also need to find, okay, wow. That's what happens when you stay up too late. X, Y, you can't think. What's dy dx? Here we go. Negative 2 squared minus 1/2 times 8. That's 4 minus 4, which is 0. Whew! Okay, we've done it. So we would conclude, since dy dx at xy equals negative 2, 8 is 0, and the second derivative at xy equal negative 2, 8 is negative, our conclusion will be, therefore, there is a relative maximum at xy equal negative 2, 8. Bam! That is part B. Let's keep on moving. We have 2 more things to do. Part C. So we want the limit of that function. I will just copy that down. Okay, g. So g of negative 1, they tell us, is 2. So the top's going to be 0. I bet you it's L'Hopital's. I'm just guessing. The bottom is 0. Do not say this equals 0 over 0. That is not correct. This is indeterminate. We do not know what's happening at that point. We have to use L'Hopital's. It might be undefined, but we don't know that. We can't assume that. So you would have to show that the limit of the top is 0, and the limit independently at the bottom is 0. Therefore, by L'Hopital's, I don't even know you have to write that. If you show that the bottom and top go to 0, therefore by L'Hopital's, this equals the limit as x approaches negative 1. The derivative of the top is g prime of x. The derivative of the bottom is 6x plus 1. I'm doing the chain rule, where x plus 1 is a box, so it's 6 box to the first time derivative of the box. Now, what's g prime at negative 1? Well, did we find that earlier, or we're going to have to figure that out? We are going to have to figure that out, I believe. Yeah, because we have the derivative, so we're going to take this equation and plug in negative 1. So dy dx, where x equals, oh, whoa. Let my brain think, oh, they give us that one. No, they don't. They do, they don't. Let me see. Sorry, guys. Am I missing something? Did I not see something? I'm not sure. Okay. The bottom, I can do that. Is it going to be 0 over 0 again? Let me see. Hold on. That's H. G. G is a particular solution. G of -1 is 2. Oh, okay. We're going to have L'Hopital's again. L'Hopital's again. So the limit as x approaches -1 of g prime of x is 0. The limit as x approaches -1 of 6x plus 1 is 0. Now, why is g prime of x 0 at -1? Honestly, I am not sure at this point. Let me think about it and figure that out. I'm just looking at the scoring guideline. So we have a L'Hopital's again. Therefore, by L'Hop, whoops, got that in the wrong spot. We're going to have the limit as x approaches -1 of g double prime of x over 6, yeah, just 6. And the top part, g double prime, they say is -2, and that's our answer. Now, okay, I know what's going on. So here's what's happening. How'd they find this, g prime? Well, you know the point is -1, 2. So I was on the right track. xy at -1, 2, because that's the point right here. You know -1, 2. So if you plug that into dy dx, did we do this already? No, it was a different point, I think. Yeah. -1 squared minus 1/2, 2. And that's going to be 1 minus 1, which is 0. Okay, that's where that comes from. The second derivative, we have that. So d2y dx squared at xy equals -1, 2. And we found this, we have the second derivative, or we found it actually way up yonder. Oh, part A. I see it in the top left there. So it's 2 times -1 minus 1/2, -1 squared minus 1/2 of 2. And that's -2 minus 1/2, 1 minus 1. So that's just -2. That's 0. There. H double prime is -2. That's how you get the answer. Whew! I was feeling kind of dumb there for a second or a half a second. Part D. Whew. H of x be the particular solution. We want Euler's using 2 steps. So we want h of 1. We have h of 0. And we want to do 2 steps. 2 steps. So if you're going from 0 to 1 in 2 steps, clearly the steps are a half a step. So we're going to make a table. If we're doing 2 steps, we need 3 lines. We have our x column, our y's, and then we have our step size, delta x. Then we need the derivative at that point. And so when you multiply these two together, it equals delta y. So our starting point is 0, 2. They gave us that. Our step sizes are 1/2. We know that. So we have to find the slope dy dx at 0, 2. So if we plug in 0, 2 into the original equation, so if we plug in 0 here and 2 there, we're going to get -1. And you multiply those, the delta y is -1/2. So our delta x was 1/2. So this will be 1/2, and then we go up 1/2 again, so we'll be at 1. We started at 2. Our y decreased by 1/2, so it's going to be 1.5. So now we have to find dy dx at that point. So I probably should have done this. Dy dx at xy equals 0, 2 equals -1. Dy dx at xy equal, no, the second, yeah, I'm okay, not the second. At our new point, 1/2, 1 and 1/2 equals, and now we have to go back to the equation, equals x squared. Did I plug it into the wrong equation? I think I did. No, I didn't. Did I? I am so confused. How did I get that -1? Did I plug it into the right one? I hope I did. I think I did. Okay, relax. I think I did. I'll see if my answer comes out right. So it's going to be -1/2 minus 1/2 times y. So it's going to be 3/4. So it's going to be 1/4 minus 3/4. That's -1/2. So that's going to be -1/4. So if this decreases by 1/4, it should be 1 and 1/4. So h of 1 is approximately equal to 1 and 1/4. Is that the answer? Yes! 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 I did it. That's it. Done. Hope that's all good. Bye.